Let's take a look at ratios of similar figures and the ratios of their areas. A couple general tips I have for you when we're doing this is to make sure that you're comparing like parts. And then I usually like to write a proportion to solve with my ratios because that eliminates me. Maybe do I multiply, do I divide? It just kind of makes an equation that's a little easier for me to solve, a little more straightforward. So first we'll start with this one, and this one came from your homework. You may recognize it. It says a hotel in Las Vegas is famous for its large-scale model of the Eiffel Tower. The model, built to scale, is 128 meters tall and 41 meters wide. The real tower is 324 meters tall. How wide is it? So to set this up, I'm going to compare height to width for both the model and the real tower. So I'm going to set up my fractions as 128 over 41. Those are both off the model, and then the 324 compared to the unknown width of the base that I'm trying to solve for. And then once I get to this step, I can just go ahead and use my cross products property and multiply 41 times the 324 and 128 times x. Then I just need to divide both sides by 128 to find out the width of the real Eiffel Tower. This next piece of information looks at the ratio of the areas. You have learned that if two figures are similar and have a ratio of similarity of A to B, the ratio of the perimeters is also the same, but the ratio of the areas turns to A squared to B squared. So the area ratio gets squared. Let's look and apply this to the problem here. The figures at right are similar. What is the ratio of similarity? Since P and Q are similar, I need to find two corresponding sides. And I've found that with the 3 and the 7. So the ratio of similarity would be 3 to 7. So then let's apply this to find the perimeter of P and Q. To find the perimeter of P, I'm simply going to add up all the sides and get an answer of 21 units. Then I'm going to use the fact that this has the same ratio as the figures to write a proportion. Now, since I have 3/7 for my ratio of similarity, that is also the ratio for my perimeters. So I can do small side over large side, 3 over 7, and then small perimeter over large perimeter, 21 over P. Again, I'm going to use my cross products property to multiply and then solve. I did not have to find every side to find the perimeter of figure Q because I know that they must have the same ratio as the 3 and the 7, the 21 and the 49 must. And then lastly, I want to answer part D. Part D says if the area of figure P is 34 square units, what is the area of figure Q? So in order to solve this, I need to again go back to what the original ratio of similarity was. That ratio was 3 over 7. I know the area ratio is that squared, or 9 over 49. And I'm going to set that equal to the ratio of the new areas P, which is 34, over the area figure Q, which I don't know, so I'm going to call that x, and then I'm going to use my cross products property and solve. So setting up my cross products, sides get 9x equals 49 times 34, and then I'm just going to divide both sides by 9 to get my answer, giving me an area of 185.111 square units.